Hi, this is Thomas. Welcome to math class. Today's topic is probability. Let's begin by talking about some basic probability concepts. Probability is the possibility of or the likelihood of an event happening. And we can have using probability notation, the probability of event E can be a range. If we know something is impossible, then the probability is 0. There's no chance of this event happening. And if we know an outcome or an event is certain, then we would describe that probability as 1. So we're always looking at a range of greater than or equal to we can say that 0 is less than or equal to the probability of a given event, which is less than or equal to 1. We can't have a probability less than 0, nor can we have a probability greater than 1. Let's consider the example of rolling a die, which has 6 sides. 1, 2, 3, 4, 5, 6. And the probability of rolling a 3 is 1 over 6. So this is the number of acceptable outcomes based on our criteria. And in this case, the criteria is the value 3. Number of acceptable over number of possible outcomes. There are 6 possible outcomes, 1, 2, 3, 4, 5, 6, and there is 1 acceptable outcome, which is the value of 3. And notice that the result 1 over 6 is greater than 0 and less than 1. So that falls into the range 0 to 1. We can write the probability as a fraction, 1 over 6, or we can write the probability as a percentage, 16, and I'll round to 1 decimal place in this example, 16.7%. And I can also write the probability as a decimal, 0.167. All of these reflect the same probability, 1 in 6 probability, or 16.7% probability, or 0.167 probability. In this case, in the case of the probability of rolling a 3 when we roll the die equaling 1 over 6, this is a type of theoretical probability. In other words, we haven't actually rolled the die, we're just doing some math based on what we know about the die to calculate that the theoretical probability, given 6 sides, and only one of them has a 3, theoretical probability of rolling a 3 is 1 in 6. Now let's look at a concept that applies when we actually do something and evaluate the results of our action, the results of our experiment. And we can evaluate actual results using the concept of relative frequency. So what I'm going to do is I'm going to roll the die several times and record my results and calculate an estimated probability based on those results. So let's say that I'm looking at number of rolls, and I'm evaluating 3. So I want to also know number of 3s, and then I can calculate my estimated probability. So I roll one time, the number of 3s in that roll is 0. My estimated probability would be 0, because I've rolled and I did not get a 3. So as far as I've seen, I don't get a 3 value when I roll the die. Second time I roll, I do get a 3. And now I can evaluate based on having rolled the die 2 times. I have 1, 3, then my estimated probability is 1 over 2. When I roll 2 times, I get a 3 one time. Let's keep going. Let's say the next roll, I roll the 3rd time, and I get a 3 again. And so with this additional 3, now my number of 3's is 2. And so my estimated probability, based on my experiment, is 2 over 3. Now we know based on the theoretical probability on the left side of the screen that we're not expecting 2 over 3. That's far off of 1 over 6, our theoretical probability. What's happening is we've only conducted a very small number of experiments. We've only rolled the die 3 times. If we were to roll 10 times, that wouldn't be a big number. If we were to roll 100 times, then we're getting to a more significant number. Let's say that we were to roll the die 1,000 times. And let's say the results after 1,000 rolls are 190 3's. So my estimated probability is going to be 190 over 1,000, which equals 19 over 100. Now looking at our theoretical probability, looking at our fraction of 1 over 6, or I can even continue, let's look at this from a decimal standpoint, 0.19. Now comparing that decimal to the theoretical probability of 0.167. They're close, but they're not exact. So again, even with a large number of experiments, the results aren't exactly matching the theoretical probability. The theoretical probability is theoretical. If we roll 1,000,000 times, then we'll get closer to 0.167. Now it is possible that you roll 6 times, you get exactly 1 3, and then your relative frequency would be 1 in 6, and that would exactly match the theoretical probability. But usually there will be some difference between your relative frequency and your theoretical probability, and the general rule is that the more times we experiment and record our results, the closer our estimated probability, which is what we're recording in the relative frequency analysis. This is estimated probability. So the larger the number of experiments or trials, the closer our estimated probability will be to our theoretical probability. And let's look at one more concept with the 1 die example. The probability of an event occurring is the same as or equal to 1 minus the probability that the event does not occur, which I'll write as E prime. So the probability of an event is 1 minus the probability of the event not occurring. So as an example with the die, the probability of 3 is 1 minus the probability of 1, 2, 4, 5, or 6. And we have calculated a theoretical probability of 3 of 1 over 6. And this is equal to 1 minus the probability of us not rolling a 3, which if we calculate the individual probabilities of a 1, a 2, a 4, a 5, or a 6, which are all individually 1 over 6, and we add those, then we will have 5 over 6. And this is a true statement. 1 over 6 is equal to 1 minus 5 over 6. If you were asked the question, what is the probability of not rolling a 3 given a 6-sided die, with sides 1, 2, 3, 4, 5, 6, in particular with only one side having the value of 3, then instead of calculating all of the probabilities of the outcomes that aren't 3, you can simply calculate the probability of a 3 and calculate 1 minus that probability to get the result, the probability of not rolling a 3. So now that we've seen some probability concepts, let's think about how we can apply these tools. If I want to know, based on rolling a die 60 times, what number of threes am I expecting? How do I answer that question? Well, it depends on whether I want to use my theoretical probability of 1 over 6 or my estimated probability of 0.19. If I were to apply the theoretical probability, 60 times 1 over 6 gives me 10 threes, and 60 times 0.19 gives me approximately 11 threes. And again, because the estimated probability wasn't the same as the theoretical probability, my outcomes based on 60 rolls aren't the same. They're close, but they're not exactly the same. This concludes Lesson 1 on probability. Be sure to practice these concepts with exercises from your textbook. In Lesson 2, we're going to look at the concept of probability relating to combined events and learn about tools to help us analyze combined probability. I look forward to seeing you then.